Students, in the previous video we have seen what correlation is and how we express this in terms of scatter plots or diagram. We have seen the positive relationship when the points are towards the upward direction. Then we have it is also positive. This is negative direction when the points are going downwards, and there is a case of no relation. Now every time to draw the diagram for a given data is not possible. Sometimes data is so large that you cannot plot each point and check the trend whether they are positively related or negatively related, or they are not related at all. So we need a fixed value that is called coefficient of correlation. So this gives us the degree of relation between two variables. So main that correlation coefficient we study is Pearson's correlation coefficient. It gives us the nature and strength. Nature means is it positive, negative or zero. So three type of nature it can have. And then the strength. Strength means if the value of the coefficient of correlation is more, that means they are more closely connected. The variables are positively more related to each other, and if it is less, that means there is not a big value to express it. It means they are not very much related to each other. So how we check it? Now come to this the nature depend upon the sign of r. Sign means positive, negative or zero, and value, what is the value of r? That give us the strength of association, means how much they are related. Now the positive sign, if the value of r that we calculate, that we will calculate in the coming lectures. So if the value is positive, it means the relation is direct means positive relation, means if one quantity is increased, second is also increased. If one is decreasing, other is also decreasing, means they are going upward or downward together. That type of relationship is called positive. Now the second type, if the coefficient of correlation is negative, that means they are opposite to each other, means if one quantity is increasing, the second will be decreasing. If the first one is decreasing, second will be increasing. They are oppositely related to each other, so that is called negative relation. And one more thing very important, that the value of r, the coefficient of correlation, it does not have any very large value. The value of r must lie between -1 to 1. It cannot be less than -1 and cannot be more than 1. It will be something between -1 to 1, right? So here it is a this you can see a line where there is 0 in between, and here is -1 and here 1. So if the coefficient of correlation that we will find using the formula, if it is here in -1, if this in this position, if it is on -1, then it is a perfect correlation, but it is inverse. It is a strong relation because the value -1 is more, but it is negative. That is why they are oppositely related to each other. If one is increasing fast, then second is decreasing fast. And if the value is 0, if coefficient of correlation is 0, it means it is a weak relation or no relation, because they don't depend upon each other. So this is this give us the no relation at 0. Then we have at 1. At 1 again we have perfect correlation, where the strength of the relation is strong. So at 1, look, at -1 and at 1, both are strong and perfect correlation. And when it is going towards 0, the strength of the correlation will be weakened, right? So these are the values. Now if r is 0, as I have told you earlier, it means the correlation between two variables does not exist, no association or correlation. If r is lying between 0 to 0.25, so that is near 0. 0.25 is near 0, so the value which is near 0 give us weak correlation. And when it is more than 0.25 or less than 0.75, it is intermediate. You can say it's not very strong, not very weak, it is intermediate correlation. For the third case, if this value of R is more than 0.75 and less than 1, that means it is a strong correlation, and if it become 1, that is a perfect correlation. So these are the positive values that R can have, according to which we can say whether these are weak, intermediate, strong or perfect correlation. Now here is the formula to compute the correlation. The formula is a little bit lengthy, you can see, but it is the only formula that we are going to use now. So to find R, what we need summation of xy. What are xy? Xy are the two variables that will be given. You will be given the data, here one example. So you are given this age and weight. These are the serial number we can put from ourselves. So age is given, weight is given, we name one as x and other as y. So this is the data. When you add these values, you will get summation x and summation y. So the sum of these will be summation x and sum of these quantities will be summation y. And if we multiply these two, x into y, we create a new column xy. So you will product xy and get the sum xy. In this way you will have all the values that are mentioned in the formula, right? Like in this case you can see, okay, here it is sigma x, sigma y, sigma xy. When you multiply x into y, like 7 into 12, 84, 6 into 8, 48 and so on, we multiply the variable x and y and create a new column xy. Similarly create a new column. Here is new column x square. We are scaling the values of this, and now x square, afterwards we have y square. So you create these three columns from yourself. X and y will be given. You multiply these two columns, you get xy. Scaring first column x, you get x square and then y square. Now in the total row, you have to add the quantities in the first column, second column, third, fourth and so on. You have to add all these quantities here. Sigma y. Sigma means summation of all the terms that are here. Adding these you will get sigma x, adding these will get sigma y, adding these you will get sigma xy. This will give you sigma x square, this will give you sigma y square. Sigma is this symbol, this is sigma. So we calculate all the values. Now what we have to do, we have to put all these value in the formula. So what was the formula? So we come to the formula. This was the formula, where what you need, we need sigma x square, sigma x, sigma y, sigma x square, here sigma x whole square, sigma y square, sigma y whole square. And what is n? N means how many quantities you have. So in this case, the question we are doing, we have only 6 values. So here we have n is equal to 6 in this case. You put n is equal to 6 and rest of the quantities we will put from here. And after solving this, you can use the calculator to solve this value. You get r is equal to this. What does it show? R is near 1. So if you plot on real line 0, minus 1, 1, this 0.75 will be here something. So it is near 1. It means it is a strong correlation, right? So I want you to solve this question, this example on your copies, and we will solve more in the coming lectures.